Hello Year 8, it's Miss Shearman here. I'm going to talk over this PowerPoint just to make it easier for those of you who like to hear what is being addressed on the screen. Okay, so if you could complete your Do Now task in your Google worksheet, so you need to have this video open and the Google worksheet open at the same time so you can pause the video and carry on with your work. So if you complete this now. Okay, so here are the answers. Okay, now the group 7 elements are non-metals. Okay, so they are here in the periodic table and they are not metals. They are referred to as the halogens. They have low melting points, which means the temperature is very low before it's able to be in liquid form. So the physical properties of group 7. So we're going to talk about these physical properties over the next couple of slides. In group 7, the melting point increases from top to bottom, unlike group 1, which you would have already done, where melting point decreases from top to bottom. Okay, so fluorine has a melting point of minus 220 degrees C. Okay, but it has a boiling point of minus 188, so that's very cold. So at room temperature, it is a gas, because melting point, remember, means when a solid is turned into a liquid, and boiling point is when a liquid turns into a gas. So chlorine's melting point is minus 101 degrees, and its boiling point is minus 35. So at room temperature, it is also a gas. Bromine, however, its melting point is minus 7 degrees. So typically at room temperature, it's going to be a liquid because it would have melted from a solid to a liquid at anywhere that's warmer than minus 7 degrees. But its boiling point is not until 59 degrees. So you would have to apply heat to it for it to become a gas. So at room temperature, it's a liquid. Okay, as you can see here, we're going down, fluorine at the top. It has the lowest melting point, and iodine nearer the bottom has one of the highest melting points. Okay, so in your Google worksheet, I want you to look at this table and answer these questions, please. And this fifth one here is a stretch question. And although astatine, which is at the bottom of the periodic table, which is in your Google worksheet, so you have the periodic table there, it is not on the list, but do you think its melting point would be higher or lower? Pause the video while you complete this task. Okay, here are the answers. Hopefully you are honest and you don't amend your answers. Remember, this is all about learning. Making mistakes is how you learn. Okay, so the physical properties, its colour. So what happens to the colour of elements as we go down the group? Well, as you can see, fluorine's at the top, iodine's near the bottom, they get darker. Now, chemical properties. The group 7 elements are all really, really reactive, and they react well with iron. So iron and chlorine makes iron chloride. Iron and bromine, remember chlorine and bromine are halogens, and they react, both of them react really well with iron. So iron and bromine make iron bromide. Iron and iodine, what do you think that would make? Iron iodide. But their reactivity decreases as we go down the group, unlike group 1. So astatine, for instance, would be the least reactive. Okay. What is the symbol of the least reactive halogen? Well, I've just given you the answer. Okay. So I'm going to allow this video to play. It is a reaction, as you will see. Okay, this video does not play in this format. So what you need to do, if you would like to watch this video, is go to the PowerPoint and play it. So it's within the PowerPoint, and really what it shows is that sodium hypochlorite, which was the liquid, is added to sulfuric acid, and when it reacts, so you have sodium hypochlorite was added to sulfuric acid, it made sodium sulfate as a reaction, hypochlorous acid and chlorine gas. So just by adding two liquids together, one of the products was chlorine gas, and we know chlorine is a halogen, so we know it reacts really well with iron. So what also happened in the video, which I really suggest you go and watch, was that the chlorine gas was rising out of the from the liquid, from the reaction, through the bottle, and iron wool, so bits of iron were heated with, so energy was used to heat the iron, and it was placed into the bottle. Now, the chlorine gas was in the atmosphere, in the bottle, reacted with the iron, because like I said before, chlorine reacts really well with iron, and the energy added allowed a chemical reaction to happen between the chlorine gas and the iron. Okay. So please complete task 2 in your Google worksheet. I really suggest you go to the Google Classroom, quickly open the PowerPoint and watch that video. So in your Google worksheet, answer these following questions. You may pause the video. And here are the answers. Pause the video. Okay. What are displacement reactions then? So this is another thing we need to learn, and it's really, really important. You'll do this in GCSEs. Elements near the top of the group, the halogen group, are more reactive, we said these. So these displace elements lower in the group from their compounds. So remember, a compound is when two or more elements are chemically combined. So here, what has happened? What we're saying here is a chlorine solution is pale green. Potassium bromide is colourless, but when we put them together, the mixture turns orange/brown. So what's happened? So in the chlorine solution, it's just chlorine. Now we've got potassium, which is a metal if you look at your periodic table, and bromine, which is a halogen. It's potassium bromide. We've mixed chlorine and potassium bromide, but now we've got potassium chloride and bromine. Now this is a displacement reaction. And it's really easy to see that here. So imagine this is a chlorine atom in the chlorine solution. The reason it's changed its colour is because at the end we have two different products. So we start off with chlorine solution. So that means it's a liquid solution of chlorine. Now we add that to potassium bromide. This blue one here is potassium, and this is bromide. This is chlorine. We react them together, and because chlorine is higher up on the halogen table, it's more reactive than bromine. It's basically going to boot the bromine out. It's going to take that potassium for itself. So what happens is, as they react, chlorine bonds, oh, sorry, this is potassium. Chlorine bonds with potassium and displaces the bromine. So then the bromine here, as you can see, is on its own. So as it says, chlorine is more reactive with potassium than bromine. So it took bromine's place and bonded with the potassium. In other words, bromine has been shoved out and left all alone and sad, whilst potassium and chlorine are a happy new couple. And that is a displacement reaction. The bromine was displaced by something that was more reactive. Okay, so task 3. State if each reaction could possibly happen and explain your answers. Remember, those in a higher in the group 7, displace those which are lower. Okay, you need to complete this in your Google form. So pause this video and go to your Google Sheet and complete it. Okay, and here are the answers. Okay, so fluorine and potassium chloride forms potassium fluoride and chlorine. Yes, that can happen because fluorine is higher up in the halogen group. It's more reactive than chlorine, so it's going to take that potassium away from chlorine. However, iodine is not more reactive than chlorine. So this reaction cannot happen. Potassium chloride is potassium and chlorine together. Iodine is not as reactive as chlorine, so it's not going to be able to take potassium away from the chlorine. Okay, so this reaction can happen as bromine is more reactive than iodine. This reaction here in D cannot happen because bromine is lower down than chlorine, so bromine will not take away sodium from chlorine. Okay, so that's the end of this video. I hope that makes sense. Go over it again, answer your questions. If you have any problems, email your teacher. Okay, thank you.